Not an ordinary silence, but one so vast it feels as if the universe itself has paused, holding its breath in the darkness between stars. Out there, beyond the faint glow of distant suns, space is not empty. It is a deep and restless ocean of invisible motion, filled with drifting remnants of forgotten systems and fragments of worlds that no longer exist. Everything moves, yet nothing speaks. Everything exists, yet almost nothing can be seen. Far beyond the warm influence of our sun, beyond the gravitational embrace that binds the planets into their familiar paths, something ancient begins its quiet approach. It does not arrive with spectacle. There is no blazing trail across the sky, no sudden burst of light demanding attention. Instead, it moves with unsettling calm, gliding through interstellar space along a path shaped long before our solar system fully formed. This is no ordinary comet born from the distant edges of our own system. It is something older, something foreign. A traveler shaped around another star, forged in an environment completely alien to everything we know. Its journey may have begun millions, perhaps billions of years ago, cast out from its home system by gravitational chaos. A passing star, a violent planetary interaction, or the unstable birth of a young system may have flung it into the vast darkness between stars. Since that moment, it has drifted without destination, guided only by gravity, carrying with it a history written in ice, dust, and time. As it enters our cosmic neighborhood, it reveals itself slowly. Its surface is dark and ancient, marked by radiation, collisions, and endless exposure to the vacuum of interstellar space. Each rotation exposes faint reflections and subtle variations in brightness, hinting at complexity hidden beneath its frozen exterior. It does not announce itself loudly. It appears almost reluctantly, as if the universe is allowing only a brief glimpse of something never meant to be fully understood. When modern observatories turn their attention toward it, scientists expect clarity. They expect to measure composition, calculate trajectory, and place it within known models of cometary behavior. They expect answers grounded in familiar physics. Instead, they find something far more unsettling. The object refuses to behave predictably. Infrared observations reveal uneven heating across its surface, suggesting internal activity where none should exist. Its rotation is irregular, shifting subtly as if influenced by forces not immediately visible. Rather than a passive body drifting through space, it appears dynamic, evolving, almost responsive to its environment. For the first time, humanity is not simply observing a comet. It is witnessing a visitor that does not belong to our solar system at all, a fragment of another system passing through ours, indifferent to the boundaries we define across the cosmos. Before this discovery, only a small number of interstellar objects had ever been confirmed. The first was an elongated body unlike anything seen before, showing unexpected acceleration without a visible tail. It forced scientists to question the limits of cometary physics. The second behaved more like a traditional comet, complete with a glowing coma and tail. Yet its chemistry revealed an origin around a completely different type of star. It carried within it the chemical memory of another planetary system. But this new object appears even more complex. Its motion shows subtle variations that cannot be explained by gravity alone. Small accelerations followed by slight slowdowns suggest that faint forces are continuously acting upon it. Closer analysis reveals jets of gas erupting from its surface, but unlike the smooth, predictable outflows of typical comets, these emissions are chaotic. They burst outward in multiple directions, twisting and dispersing like threads unraveling from an unseen structure. Each eruption produces a measurable push, altering its trajectory in delicate but persistent ways. Yet the pattern is not entirely random. It carries rhythm, irregular but persistent, hinting at processes occurring beneath the surface. Its chemistry deepens the mystery further. Spectral analysis points to rare carbon compounds, unusual silicate grains, and crystalline ices formed under extreme conditions. These materials suggest an origin in a harsh, radiation-heavy environment, possibly near a volatile young star or within a turbulent protoplanetary disk. This is not just a wandering object. It is a preserved fragment of another world, a piece of cosmic history carried across unimaginable distances. And yet, even within known physics, something feels incomplete. The timing of its eruptions, the direction of its jets, and the relationship between internal activity and motion suggest a complexity that feels structured, though not artificial, not engineered, but not entirely simple either. Scientists remain cautious. Hidden reservoirs of volatile gases could build pressure beneath the surface, releasing in bursts. Thermal stress could fracture the crust, opening pathways for material to escape. These are reasonable explanations. And still, the patterns persist. They repeat. They evolve. They suggest a system that is active rather than inert. Perhaps interstellar objects like this are not just frozen debris. Perhaps they are dynamic systems shaped by internal processes we do not yet understand, systems that respond to heat, radiation, and stress in ways that produce behavior far more complex than simple motion through space. In that sense, this object becomes more than a discovery. It becomes a messenger, a moving laboratory carrying information from a place we cannot reach. Every plume of gas, every flicker of infrared light becomes a line in a story written not in words, but in chemistry, motion, and time. Some researchers even connect such objects to the idea of panspermia, the possibility that the building blocks of life are not confined to one world, but travel between stars aboard bodies like this. If interstellar objects can preserve complex organic molecules for millions or billions of years, shielding them from radiation and releasing them during activity, they could scatter the ingredients of life across the galaxy. If that is true, life may not be isolated. It may be shared, distributed across systems through silent travelers like this one. Beyond the question of life, this object challenges our understanding of physics itself. For centuries, comets were seen as simple, predictable bodies. This one suggests otherwise. Its internal structure may be fractured and layered, filled with regions where pressure builds and releases in cycles. Its surface may conceal processes that blur the line between inert matter and active systems. For future exploration, this presents a profound challenge. Intercepting such an object would require more than speed. It would require intelligence. Its unpredictable motion would make traditional navigation extremely difficult. Any spacecraft sent to meet it would need autonomy, the ability to adapt, respond, and decide in real time, far beyond the reach of delayed commands from Earth. And perhaps that is the deeper lesson hidden in its passage. The universe is not still. It is not empty. It is not simple. It is alive with motion, filled with travelers that carry history, chemistry, and possibility across a vast cosmic ocean. Some are fragments of destroyed worlds. Others may be the seeds of new ones. As this object continues its journey back into interstellar space, its faint glow will fade and its motion will blend into the background of the galaxy. But its significance will remain. Because it leaves behind something more important than data. A realization that even in the deepest silence there is motion. Even in the coldest darkness there is chemistry. And even in the emptiness between stars, there are stories, ancient, complex, and still unfolding far beyond the limits of what we understand.